rule, if f and g are both differentiable, then the derivative of f times g, these are being multiplied, is f, the derivative of g, plus g, the derivative of f. That's how it will look like in your textbook. The way I write it is I go every day. I am nothing if not consistent about not grabbing the pen every day. F, G, prime. So those are being multiplied, correct? You go, most of the textbook will say FG prime plus GF prime. I will never write it that way because I can write it GF prime plus FG prime, which is, I'll show you. It's written like this normally, FG prime plus GF prime. But because it's an addition, can I not swap these and it's still the same thing? Is that true? The reason why I swap them and don't write them the way the textbook writes them is because if you swap them, you're actually one minus sign away from having the quotient rule. If you write them like this is not how the top of the quotient rule looks. So then you have to memorize two different formulas, and I choose not to go that route. So I always write the GF prime plus FG prime, so I have the quotient rule already memorized. It helps you for the other rule. Okay? So F times G prime of that, I always write it as GF prime plus FG prime. Quotient rule is GF prime minus FG prime over G squared. So it's just a minus sign over G squared. So you're not memorizing two formulas. Because addition says I can flip-flop these into the exact same thing, right? If we flip-flop them, just note to self in your textbook, if your answer is like sine x plus x squared, their answer is probably x squared plus sine x because they did FG prime plus GF prime first, right? There's just back. Same thing though. Addition this way or this way. Same thing. All right. Most people do not spot this as a product rule. They'll just do the derivative of x, the derivative of e to the x, and call it a day. So what I always say to do is put that multiplication dot in between them. So f of x equals x times e to the x. You see how I have that multiplication dot in the middle? Which screams I'm multiplying, which screams product rule. If you don't put the dot in the middle, a ton of people will just go 1 e to the x. They just do the derivative of x, derivative of e to the x, call it a day, which is not at all the derivative. Because you have to use product rule. So this is my f, this is my g. For the formula, I need a g, I need an f, I need an f prime, and a g prime. Okay? What is f prime of x? What's the derivative of x? 1. What's the derivative of e to the x? We just talked about this a lot. E to the x. So now I have f, I have g, I have f prime and g prime, right? And I need those four things to do product rule to fill in the product rule formula. So f prime of x is this formula when I have multiplication. So I'm going to put g first. What is g? E to the x. F prime. 1. Plus f. X. And then g prime. E to the x. Now I could leave it there, but that won't be the answer. Keep in mind, whenever you have any numerical base to variable exponent, your first step is to rewrite it, correct? So it will exist in both the prime and the not prime. Yes? So what we have to do after this is we have to look at term 1, term 2. With the product rule, you always have two terms. 1 and then plus sign term 2, correct? And I'll say to myself, what can I take out of both of those two terms? Is there anything common that I can take out? What? E of x, e to the x. So we're going to go e to the x, and then there's nothing else common, correct? Then I write what's left over. So term 1 is the first blue. If I take an e to the x out, what's left? 1. Some people will say 0. Remember that when you are taking a value out, a greatest common factor out, the actual operation you're doing is division. Yes? So e to the x divided by e to the x is 1, not 0. Right? So that's why when you take out a GCF out of a term, and the entire term goes away, you're actually still left with a 1. not a 0 because it's division, right? E to the x divided by e to the x is what? So keep in mind that if you have two terms, when you take a GCF out, in the brackets you should still have two terms, right? It's just simplifying it. It's not making a term go away. Okay, and then if I have this plus sign here, and then my second term I have x e to the x. When I take an e to the x out, what am I left with? X e to the x. When I take an e to the x out, what am I left with? X. Done. That's it. So is product rule itself difficult? No. The problem is going to be spotting it, noticing that there's two things being multiplied. And how do I know there's two things being multiplied? There's two variables side by side. Two variables side by side is multiplication, right? 7x and then an e to the x. Okay? The other thing to note is that when we start doing more intense, not power rule and e to the x, our derivatives, our f and our g prime are going to get harder. That's where it's going to get hard. The product rule itself is not hard. It's finding the derivative of the other things that sometimes is hard. And reducing it. So we want the nth derivative. So f to the n. So this is the catch. If I wanted to do the next derivative, what would I have to do? So that's f prime. What would f double prime be? I'm going to have to do what again? Yeah, product rule. And it's labeled product rule properly because we have the product of two things, correct? So when you have the product of two things, you use product rule. So we have e to the x and g. So this is f and g. And remember yesterday I told you if you want to find the second derivative, you have to find it from the first derivative. If I want the 10th derivative, I need the 9th derivative. If I want the 100th derivative, I need the 99th. So sometimes doing the first, second, third, fourth, fifth, you start seeing a pattern. And then that's how you can get f to the n. So we'll see if maybe if we do a few, if we start getting patterns. Okay, so f double prime. I'm going to go g, which is 1 plus x, times f prime. What's the derivative of e to the x? E to the x. Plus, so it's g f prime plus f g prime. We agree? So f is e to the x. What's the derivative of 1 plus x? What's the derivative of 1? 0. Any constant just goes away. What's the derivative of anything with an x in front of it?
1.
Whatever's in front of it, so it would be 1. So the derivative of g prime is 0 plus 1, because the x drops off, so it's just a 1. What can I do? Yeah, so now I look and I say term 1, term 2. What can I take out of both terms? An e to the x. What am I left with in the first term when I take out an e to the x? 1 plus x. Plus, what can I take out if I take an e to the x out of the second one? A 1. So what am I left with? E to the x, 2 plus x. See any patterns happening here? Any correlation to the actual derivative itself? Anyone have any idea what maybe f to the n derivative would be? Remember, I have to use n. Yeah, e to the x times n plus x. Or x plus n if you so chose to write them the other way, right? So this number 2 correlates with my second derivative. This number 1 correlates with my first derivative. And sometimes they'll end up with a pattern and we can say what the last one would be. Sometimes they're totally different every single term. You can't give an f to the n. Okay? So if I ever ask for x to the n or some prof asks you for x to the n, there's a pattern. Do enough of them, you'll start seeing it. If we do the next one, we're going to see that it was e to the x 3 plus x. The next one would be e to the x 4 plus x. E to the x 5 plus x. Sixth derivative would be e to the x 6 plus x. What would the 100th derivative be? E to the x 100 plus x, right? All right. So, differentiate the function. Oh, this sound is yours. You're going to need a piece of paper. They got real close. They're like on top of each other. I fixed Jamie's. He's the only one who doesn't have them right beside each other. So you're going to have to do example 2 on a separate sheet of paper because it's like literally on top of your example 3. It took out the space. So nice of it. So we're doing example 2 of root t, a plus b over t. I love how it just doubled up the equation 2 in this one. I saved it on OneDrive, and then when I pulled it from OneDrive, it changed it. All right. So I want to try this. It's at home here. Okay. So here, I have f of t. Does everyone see that? It is f of t. That means the only variable I have is t. Correct? So I have f of t equals, how can I write the root square root of t better? T to the 1/2. And then I have a plus bt. And then some people will say to me, Lepp, you're an idiot. There are 3 variables. True, except t is actually a variable. And what are a and b? Numbers. A is a constant, b is another number. A and b are just numbers. So if I have f of t here, that means a and b are actually just as if they'd be any number. A could be 7, 10, 22, -5, right? And b is any number. Make sense? So when you have function notation, f of t tells you that t is actually the variable. Okay? All right. So this would be my f. This would be my g. Let's do our derivatives. There's not enough room for me to do this stupid thing. Yours is even worse. Yours is like stacked. Mine just put this random equation in here, so it gave me a tiny bit of space. So nice of it. All right. So f prime is what? If f is t to the 1/2, what is f prime? 1/2 t to the -1/2. Ignore this for now. Do not cross yours off. I'm just doing this so I can actually do the work. Do not cross yours off. You're doing this on a separate sheet of paper, like I said. What is g prime then? If a is just a number, what happens when I take the derivative of a number? It goes bye-bye. And then b of t, what if this was 6t? That's not b of t, it's bt. What if this was 6t? It would be 6. So what's bt? B. So the derivative of g prime is just b. Because a and b are numbers. We agree? Yeah. Is anyone super lost right now, or does that actually make sense? Do you understand why, Kyle? Yeah. Makes sense? Yeah.
For the sake of, like, say you work with people on a test, would you be okay to just plug in numbers and figure it out?
And then put the letters back?
Would that mess you up?
You could do it for the first step of filling in gf prime plus fg prime, then put the variables right back in. If not, like 6's and 2's are easy to take GCFs out, A's and B's aren't. All right. So we're going to do f prime of t. If you are at all distracted, if you are at all not writing this down, if you are at all not paying attention, if you are at all thinking you cannot pay attention right now, I will lose you so fast your head will spin and we'll move on to the next question and you will want to be like, what the heck just happened? And I'll just keep going. Okay? If you pay attention, I will not lose you. I will go slowly. All right? So we are filling in the formula for the derivative, which is gf prime plus fg prime. That is what I'm doing right now. We agree? So we have f, we have g, we have f prime, we have g prime. I'm just literally filling those in. That is not where you're going to get lost. You're going to get lost on the GCF. So this next step is easy. So g is a plus bt. F prime. What is F prime? 1/2 t to the negative 1/2. Plus F. What is F? T to the half. What's G prime? B. Once you have that written down, put down your pencils. I'm going to need every brain cell you got. We're going to use it. This is not a hard concept. People find it hard. Okay? If I can get you on board in the next 5 minutes, you will be able to GCF these like no one's business. If I can't get you on board, you're going to be lost for weeks. So, climb on board. Ready? Pencils are down. Totally different question. Ready? If I give you a term that is t, watching, to the half, and then the other one is t to the negative 1/2. I can take out a t. Caveat. Say I gave you t to the 2 plus t to the 3. This is easy. What could I take out? A t squared. Do we agree? And when we GCF out, what operation are we doing? Division. That's it. We agree? You guys will find this one easy and this one mind-blowing. They're the exact same steps. All right? Let's think about it. If I take a t squared out of t squared, I technically have t squared divided by t squared, which is 1. Now, the reason why that is because when I have division of two bases that are the same, what do I do with their exponents? Subtract them, do I not? So this would be t to the 2 minus 2, which equals t to the 0, which equals 1. True statement? That's what you're doing without you even realizing you're doing it. Okay? Now, if I take a t squared out of t cubed, everyone will tell me it's t. Because we've done these so much, you guys find them really, really easy, which you will with these ones too. They're just brand new to you. This is not brand new. Grade 10, this was mind-blowing. So, why is it t? Because I have t3 divided by t squared. Because that's what you do when you GCF, correct? 2 bases, 2 exponents. What am I doing with those exponents? Subtracting them. And so I actually have t to the 3 minus 2, which is t to the 1. We all agree. Yes? You've done that for years. You guys just do it without thinking now because it's part of your being. You don't remember in grade 10 when you guys learned this how stressful it was. Okay? But now you find it super easy. Yes? Same thing here. You don't remember. It was stress. People cannot take out variables. They're like, I do not know how you're getting that number out of there. It's the craziest thing when you teach in grade 10. All right. So, what did I take out? The smallest exponent or the largest exponent? I took out the smallest because I can't take a 3 out of a 2. It doesn't make sense. I have 2 t's. I can't take a 3 out of 2 t's. Correct? T times a t. So what's the smallest in this one? T to the negative 1/2. Yes? Is that true? Okay. No one's writing anything down. Everyone is just taking this in. When you write, you can't use all your brain matter. I need all of it. Okay? So I'm going to take out a t to the negative 1/2. Everyone agrees that that's the smallest one, just like t squared was the smallest one over there. Yes? All right. If I take t to the 1/2 and I take a t to the negative 1/2 out, this is what I have. T to the 1/2 divided by t to the negative 1/2. Is that a true statement? Yes. When I have 2 bases that are the same being divided, what do I do with those 2 exponents? Subtract them. So what does this give me? This gives me t to the 1/2 minus negative 1/2. Over here I had t to the 3 minus 2. Yes? Here I have t to the 2 minus 2. So here I have t to the 1/2 minus 1/2, negative 1/2. Yes? What's minus a minus? What's a 1/2 minus a 1/2? What's 1/2 plus a 1/2, sorry? It's just t to the 1, isn't it? actually, when I take a t to the negative a half out of a half, I'm left with a t. That's the hard one. This one shouldn't be hard. T to the negative a half, take out a t to the negative a half. It's a 1. We agree? Okay, caveat. What if it's not a half and negative a half? What if it is t to the third plus t to the negative 2/3? Let's talk about it. What can I take out? So I can take out the smallest, which is t to the negative 2/3. Everyone knows that it's a +1 at the back, because t to the negative 2/3 take out a t to the negative 2/3 is a 1. Yes? They cancel off. Let's talk about the other one. T to the third divided by t to the negative 2/3 is the same as t to the third minus negative 2/3. What's minus a minus? What's a third plus 2/3? 3/3, which is t to the 1. So I actually have t again. That's going to happen every single time we do a derivative. And you're like, how does that even happen? Well, think about it. If my things are t to the half, if that is my f prime is going to be 1/2 t to the negative a half. What is the difference of these two? 1. Why? Because I subtracted 1 off of it. Correct? If my f is t to the third, my f prime is going to be 1/3 t to the negative 2/3, because what am I doing? Subtracting 1. So when I take that negative 2/3 out and I subtract it, it's going to be 1 every single time. So when you take these ugly fractional exponents out, you actually are going to get 1, because the 1 will cancel off, and t to the 1, because the other one will even itself out. Every single time. Does that make sense? Okay, let's go back to where we were. I don't even know where we were. I've lost my, down here. So, I have f, I have two terms. I have gf prime plus fg prime, right? I have two terms. I have this term, and I have this term. We agree? Every time I have product rule, I have two terms in which I got to see if I can take out a GCF of some sort. Is there a t I could take out of both of these? What? T, what's the lowest one I could take out? A plus B, T, and B, there's nothing I can do. Those suckers are staying for life. But what can I do with the T's? T to the negative a half. We just discussed this, right? Let's write what's left over after I take that out. So if I take a t to the negative a half out, a plus b t stays, right? Nothing's happened to that. It'll stay in brackets. The half stays. And then t to the 1/2 divided by t to the 1/2 is 1. So do I have to write anything, or is it just gone? Just gone. Okay. Plus, the b stays. T to the half, take out t to the negative a half, which is t to the 1, correct? Why? We did the math over here. We did the math on the next page. T to the half. If I GCF out t to the negative a half, that's division, which is t to the half minus negative a half, which is t to the half plus a half, which is t to the 1. So I actually am left with just a t. Does everyone understand that spot? Okay, thinking caps needed again. So once you're done, put your pencil down. They will never leave a fraction embedded in this. They will pull the fraction out. So if it's 2/3, they'll take out a third. If it's 5/4, they'll take out a fourth. If this was 3/2 instead of a half, they'll still take out a half. They just take out that bottom part. Okay? So what they're going to actually do is they will also GCF out a half. Okay? So they're going to take out this half because they're not going to leave a weird fraction in the middle, and I'll show you why they don't after this step. So they're going to take that half out of both of the terms. So I'm going to have not only take out t to the negative a half, I'm going to take out 1/2 t to the negative a half. So the t to the negative half is already out. We agree? Now I'm just going to take the half out. You could have done this in one step, but it would have been overwhelming, so I didn't do that. Okay? If I now just pull a half out of this a plus bt to the half, what am I left with? A plus bt. That one's pretty easy, correct? Does everyone agree? Take a half out of the half. Then a plus sign. Now, when you divide by a half, what's that actually the same as? We talk about it all the time in 30-1. Dividing by a half is like multiplying by 2, is it not? True? What number do I have here? I have a 1. Do we agree? So what am I doing? I'm going 1, and then I'm taking out this half, yes? Which is the same as saying 1 divided by a half, correct? Because GCFing is a half is divided every single time. So what's 1 divided by a half? Well, that's 1 times 2 over 1. So it actually becomes a 2. So we're going to get 2 BT. Do I need the A plus BT in brackets? Or is that brackets a little bit of extra for no reason? I only need brackets if these are multiplied. They're not. There's not even anything in front of it. So the A plus BT actually doesn't need to be in brackets. So is there something else I could do there? Yeah, I have 3 BTs. And what they'll do, this is the reason why they pulled the half out. Sorry, this is horrific. I'm going to bring this up here. I need to use my other computer. This one, I have a conundrum. This computer has the calculator, so I can show the calculator. The other one has the extended page. So I'm like torn as to which computer. I love the extend page. Doesn't have the computer on it. I need to get them to move the computer to the extend page computer. All right. So what they're going to do is 1 over 2. I can leave the 1 on the top, and I can put the 2 on the bottom. Right? That would be numerator, denominator. Yes? 1 on the top, 2 on the bottom. The 2 to the negative, t to the negative a half, where could it move? To the bottom and become what? T to the positive a half, could it not? Can I move this from the numerator to the denominator, make it positive? And then you guys said A plus 1 BT plus 2 BTs is 3 BTs. So I can get on the top 1, which would be just A plus 3 BTs. Do you want to know what's great? Example 3 is way easier than example 2. So you have example 3 at the bottom of your page. Mine I have scraped off because it's stupid and I got swished. I'm going to write mine on the second, on a new page. So once you have that written, I'm going to switch pages. All right. So this one tells me, example 3 says, f of x equals root x g of x, which are 2 things multiplied. Do we agree? Are those 2 things multiplied? Root x times g of x. And then it says where g of 4 is 2, g prime of 4 is 3, and they want me to give them f prime of 4. So I have f of x. I technically need f prime of x. Yes? Which is the first derivative? Do we agree? How could I rewrite f of x to be helpful? Because whenever you have square roots, you can't keep them that way and do a derivative of them. That's not a form that's helpful. You need a rational exponent for them. So I would rewrite f of x equal to x to the what? X to the half times g of x. We agree? I didn't do anything crazy there, right? I just wrote root x as x to the half. So this is my F. This is my G. My F prime is what? 1/2 x to the negative 1/2. And what's the derivative of G? G prime of x, that's it. So G prime would equal G prime of x. It's not actually a function, it's just G, right? So I can replace G prime with G prime of x. It's not an actual equation. It's not like x plus 7. So my formula is G F prime plus F G prime. So let's fill in what I know. F prime of x. What is G? G is just G of x. Nothing crazy. Yes? And what is F prime the same as? 1/2 x to the negative 1/2. Plus what's F? X to the 1/2. And what's G prime? G prime of x. Now this might look super confusing if they didn't ask us for this. They didn't ask us for F prime of x, they asked us for F prime of what? 4. So let's find that out. F prime of 4 equals, now for every x becomes a 4, correct? G of 4 times 1/2 4 to the negative 1/2 plus 4 to the 1/2 times G prime of 4. So F prime of 4 is what we're finding. We have G of 4. What is G of 4? What do they tell us? What is G of 4? G of 4 equals 2. So I can take G of 4 off my board and rip it off and put it as a 2. Times. What is this? What is the 1/2 of 4? Well, 4 to the 1/2. Ignore the negative. What's 4 to the 1/2? That's the square root of 4, correct? Which is 2. If it's to the negative, what does it become? 1/2. Remember, it just moves to the bottom. If you want, you can rewrite this as 1 over 4 to the 1/2. Yes? Do you know? 4 to the negative 1/2. I can rewrite it as 1 over 4 to the 1/2. And then that would be 1 over 2. And anything that's part of a 1/2 is its root, which is square root. And then here I have 4 to the 1/2. So that's the square root of 4, which is 2. And then what's G prime of 4? They gave it to us. It's 3. So now I get 2 times 1/4 plus 6. 2 times 1/4 is 1/2 plus 6. So it's 6.5. We will do more in a second here, but I want you to practice a couple of these. So, we will come back, don't worry. But right here is your, actually, we're going to call it, I want you guys to try these. These are all product rule. If you want to try one like we just did, the ones we just did are the 43A and the 45. These are like that example 3 like we just did. So start working through them. As long as you work, I'll give you the rest of class to do them. I will not move on to quotient rule. If you don't work, I will move on to quotient rule. So work, because when you get stuck, you can ask a question. Okay?